Okay, guys. So this week we're going to continue on with electricity. We're going to do a little circuit analysis. And so if you look here, the big goal is we want to be able to use Ohm's law to find the change in voltage across any device in a circuit. In other words, it's a system problem. We're going to take what we have to get what we need to find what we want. In other words, we're going to take what we have, which is the resistance. We're going to find what we need, that's the total resistance, to get our current so that we can then solve for the change in voltage. Okay? Take what we have to find what we need to get what we want. Okay, so let's go ahead and look at the system from the other day. Now, so this should look familiar, and we talked about how we are going to calculate the resistance total. Okay, because what we want to do is we want to find the overall resistance so that we can use that in Ohm's law to then find the current. So we know this relationship. We know that the voltage is equal to the current times the resistance. This voltage we have, that's our 20-volt battery. This resistance we're looking for, that's what we're going to be after. And then this current we're going to be calculating. Okay, so we're always going to calculate the current, and then we're going to apply that back to our question. So, like, let's say, for instance, we wanted to find the current across this 2 ohm light bulb that we have in here. In other words, we want to know what is the change. I'll get rid of that. We want to answer this question. We want to know the change in voltage across the bulb. Okay? That's our ultimate goal, is to understand that. Okay? So we need to first start by finding the resistance of the system. So to do that, you know, we have to look at our system, and I'm going to start here. Okay, the most complex part of the system. So the first thing I'm going to do is find the resistance of this parallel system here, where I have a 3 ohm and a 5 ohm resistor. So we know in a parallel the resistance is equal to 1 over the resistance of, you know, the parallel, which is 1 over 3 plus 1 over 5. Now, one thing that we didn't do well the other night is we're going to solve it this way. We're going to solve this part and then plug that value in and take the inverse of it to get the total resistance for this part of the parallel. So if I take 1 over 3 plus 1 over 5 and I take the inverse of that, I get, for this parallel, this part right here, I get 1.88 ohms. Now that gets us started, because now we see that with the 6 ohm resistor that's right there that is now in series with it, we could simply add that 6 ohm resistance to it, because in a series we just need to find the sum of the 2 resistors in the series. So for this entire branch now, we have 7.88 ohms. If we look over here at this branch, we have 15 ohms and 2 ohms. Let me change colors here. 15 ohms and 2 ohms. And so because it's a series, I know that I'm going to do the sum of the resistances. So I'm going to take 15 ohms plus 2 ohms. And for that I get 17 ohms of resistance. So now I can consider the larger picture here, which is all of this together, these 2 branches, which are, again, in parallel. So when I'm doing parallel, I have to deal with the inverse of the resistance. So I'm going to take the inverse of one branch, which is 1 over 7.88 ohms. I'm going to add that to 1 over 17 ohms. And then I'm going to work it like this, take the value and take the inverse of that, and I should get something like 5.38 ohms of resistance for all of my resistance except for my last little piece, which is this piece right here, my 10 ohm resistor. But because it's now in series, I could simply just add my 10 ohm resistance to that, and I come up with a resistance for the circuit, the total resistance, to be 15.38 ohms. Okay, so we've done a little bit of circuit analysis. We've been able to solve for this resistance here. We know the voltage. The next thing we're going to do is to solve for the current. Okay, so we're going to take our 15.38 ohms of resistance and our 20 volts of potential, and we're going to work out and solve for our current. So voltage is equal to the current times the resistance. If I want to solve for that, I'm going to take the voltage divided by the resistance to give me my current, and that means I'm going to take 20 volts divided by 15.38 ohms, and I'm going to get something like 1.3 amps or amperes. Okay, now this is our calculated current amount, and here's what's really important about this calculated current amount. It does not change. It's static. If we think about our water system, the amount of water in the system is not going to change. This is the amount of current that we have. And that is true everywhere throughout the system. What we want to do is find how much does that pressure or how much does the voltage change across some device. So if I look back here and I was talking about our bulb, which happens to be a 2 ohm bulb, then I could say, well, voltage equals, or change in voltage equals the current times the resistance. I know my resistance now, that's 2 ohms. 2 ohms. I know my voltage, or my current, that's 1.3 amps. And so if I take 1.3 amps times 2, I get 2.6 volts. That is the change in voltage across that bulb. Okay? So what we could do the same thing for a 10 ohm. We could say, well, we have a 10 ohm resistor, 1.3 times 10, I would have a change of 13 volts. And we could do this for any object in our system once we know the total resistance and we have calculated the current for the system.